Hello, today I'd like to talk with you about a new method of rectification by personality traits. Is it possible to rectify a chart based solely on the analysis of personality? It may seem incredible, but as we've seen previously with the matching protocol study, the personality portraits done by Mastro experts are so precise that we can just use them to rectify the time of a birth chart without using events. All birth times of the form XX00 or XX30 are very questionable even if they are AA because of the rounding. I have a statistical argument to support that claim. Here is a distribution of birth hours. These data come from a Gauquelin file of French notabilities. The times have been rounded in 12 intervals of 5 minutes each. In fact, there are much too many births whose time ends with 00, nearly 72%, which is more than 8 times the expected value. This is obviously totally unlikely if we correctly assume that the births are distributed uniformly from 0 minute to 60 minutes. Analyzing this table shows that in 72% of the time, even if it's AA, there are rounded hours of the form XX00, and that in reality could range from minus 20 minutes to plus 20 minutes of the official time. For the statistical study which follows, we will experiment something that is not even possible for rectification from events. We will try to rectify for subjects as if we had no idea of their birth times with an objective method using a list of their personality traits. In my previous matching protocol, lists of biographical traits were compared with lists of astrological traits generated by Mastro expert. I then used an automated mathematical tool to compare the two lists. The semantic proximity estimator, which is a measuring instrument that calculates the level of semantic concordance between two lists of words. To rectify the birth time of a subject whose only the birth date is known, I will compare his biography with the 1,440 possible astrological charts for each minute of his birthday. In other words, using the semantic proximity estimator for a given subject and a given birthday, we can try rectifying a birth chart by calculating 1,440 charts in 1 minute increments. We can do a better job by putting in memory the results. I open here, autosave on, and we're going to do with 24 hours. So I'm going to start at 0. I'm going to ask for 1440 minutes in a day, and I start, and it's going to put all the results in an Excel sheet. For each subject, the estimator will calculate 1,440 scores by comparing each of 1,440 charts with his biography. At the end, we obtain all those scores expressing the degree of concordance between the psychological portrait and each of all the different astrological descriptions over 24 hours. Then, with those scores, we can draw a 24 hours graph and look at its maximum values, peaks. The result we obtained for 1,440 minutes tested within 24 hours seems almost too good to be true. It looks like cherry picking, and a statistical verification is required. How can we validate any rectification method? Some may argue that the actual birth times are not reliable targets and that they are precisely what we try to rectify. But there is a statistical way to overcome the difficulty. Even if we cannot rely on the exact legal time, we can still assume that on average we should fall reasonably close to the legal time. Indeed, a rectification technique could be validated by showing that even if it does not correspond to the exact legal times, it finds solution reasonably close to the legal times in a way that defies the laws of chance with a significant p-value. To check if this method of rectification really works, and for statistical validation, I followed a simple protocol. I took 42 subjects whose biographies I already had, and I calculated 1,440 charts for each one from midnight to midnight. I think that the technique could be considered as reliable if it gives us consistently a peak sufficiently close to the official time. In other words, if the method of rectification is correct, we can expect to statistically get among the highest peaks of the curve at least one peak located at a reasonable distance from the official time. It's a matter of defining the rules of what will be called a reasonable distance. 1. What is the number of acceptable peaks? 2. What is the maximum possible time deviation from legal time? Just to illustrate the kind of problem that we face, let's take the case of Bill Clinton for example. As an indication, here are in order the keywords found first for his biography, second for his official birth time, and third for his rectified birth time. First, the bio portrait. 58 words. I'll let you have a look. Now the official birth time, 197 words. Then the astro portrait for the rectified time at 8:48, 201 words. It would take a great deal of thought to make the distinctions needed to decide which astrological description best matches the biographical description. It would be extremely difficult to make all the comparison needed for a final decision without the help of the semantic proximity estimator. The semantic proximity estimator evaluates at 1.77 the value of the concordance score between the bio portrait and the rectified astro portrait, while the score measured for the official time is lower at 1.68. And in this example, we had only two comparisons to do, whereas for the complete study, we need a total of 1,440 times 42, 60,480 comparisons. If I can establish that we significantly have a peak among the major peaks that falls near the official time, that would be a very convincing argument both in favor of this method of rectification and in favor of astrology. Let's begin with a few examples. Looking at the rectification graph for Clinton, we know that 1.77 is one of the highest peaks at 8 hours 48 minutes among all the possibilities. From midnight to noon 38, 8 hours 48 minutes gives the best solution. As for Clinton, in some other cases, the verdict is easy to do with the naked eye. Here is the rectification for Pablo Picasso, whose official birth time is 23:15. In this case, the most likely solution is given by a peak at 23:36, which comes in first position among all the possibilities. Here is the rectification curve for Boris Yeltsin, whose official birth time is 12. We see a peak at 11:34, which comes in third position within 24 hours and which gives the best solution between 9:37 and 24 hours. But The three examples that we've just seen may have been cherry-picked from several cases that do not work, or are they rather typical of what happens in general? Here is a case that clearly doesn't work. Albert Einstein, born at 11:30. There are less obvious cases where it's difficult to reach a verdict quickly with the naked eye. For instance, Lord Mountbatten. In fact, to help understanding, it can be seen as target shooting. The legal birth time is the bullseye represented here by the red line at 6, the official time for Lord Mountbatten. The yellow colored area represents the set of arrows that are allowed to be drawn. If this sport was completely random, the probability of hitting the bullseye by pure chance is equal to the ratio of the yellow critical zone to the entire domain. We see here that we have a hit with Lord Mountbatten. Each yellow critical zone is symmetrically defined at plus or minus 30 minutes around the 5 highest peaks. So, if there's no overlap between the yellow critical zones, the probability of success is equal to 5 divided by 24, which is close to 20%. In general, we observe overlaps, but I didn't take it into account in the model, and this worked against the final p-value and made the result more conservative. For instance, with Clinton, because of an overlap in the third yellow zone, in reality the probability was smaller than 5 divided by 24, but I took this value, which is an overestimation anyway, so that the model of the binomial law could work. Indeed, it is a conservative approach because if the probability of some success are overestimated, the final p-value will be higher, so the final result will be less significant. Here are the results of the research for the 42 notabilities. In black, coefficients used in the estimator. In yellow, first the maximum possible time deviation from legal time, here symmetrically 30 minutes before and 30 minutes after the legal time. And second, the number of acceptable peaks, here 5. In red, the results. With a sample of 42 nativities, we observe 18 success, giving us a p-value close to 1 divided by 1000, which is significant. Faced with these encouraging results, I wanted to go further and to develop a more practical application. As everyone does not have his biography in a book, I thought about using questionnaires. The method is simple. I propose to subjects the totality of the keywords collected by the astrological analysis of their 1440 charts of their birth date, and they must evaluate these words on a scale from 1 to 5. Each participant received a letter with the questionnaire. As the words in these personalized questionnaires exactly match the words in the corpus of Mastro, it is predictable that the measures proximity analogy 1 and 2 will be less useful, if not useless. On the other hand, we have a new information here that was not available in the biographies, and this is exciting. Indeed, as there's a scale from 1 to 5 in the answers, the words rated 5 are stronger than the words rated 4, which are stronger than the words rated 3. This should be partly reflected in the order of the astrological words, which are classified with their scores. This allowed me to evaluate a very important new measure with the semantic proximity estimator, the rank correlation between the two lists. In the case of the questionnaires, only the highest 3 categories were selected, corresponding to scores 3, 4, and 5. In the case of astrological lists, we use all the scores calculated by Mastro. In this study, the critical zones are symmetrically defined, this time at plus or minus 50 minutes around the 5 highest peaks. Hence, the probability of an individual's success is 50 times 2 times 5 divided by 1440. It gives us 0.3472. Here are the results for the research for 22 subjects. In black, the coefficient of the estimator. Notice that we have a 0 for analogy 2 and a weak 0.5 for analogy 1 and a big 2.5 for the rank correlation. In yellow, first the maximum possible time deviation from legal time, here symmetrically 50 minutes before and 50 minutes after the legal time, and second the number of acceptable peaks, here 5 again. In red, the results. With a sample of 22 nativities, we observed 14 success, giving a p-value close to 5.3 divided by 1000, which is significant. Let's summarize. We established that with a 24-hour uncertainty on a birth time, it was possible to reduce this uncertainty to only 5 highly probable moments with a personality-based rectification method. At this point, it remains to consider these few likely moments to choose the best one and increase its accuracy by fine-tuning using a standard method of rectification from events. When they hear the word statistics, many astrologers think that it has nothing to do with astrology, that it's good only for nerds. They think that talented, intuitive, true astrologers connected to the source do not waste time with statistics. But what is statistics? It's just honesty. I hope you enjoyed this presentation, and above all, I hope that it can inspire you for your own research. Thank you.